Earth's mass extinction events explained in 20 minutes. Or, the relentless tenacity of the cephalopods. Life on Earth has taken a very bumpy ride throughout its history. And I don't mean just since Trump decided to take a run for the presidency. This has been going on for a while. If you dig into the ground, where they keep the fossils, you begin to see a pattern repeated in the dirt, multiple times. From bottom to top, it goes like this: sparse fossils, then a little more fossil diversity than before, and then exponentially more and more fossils, then suddenly, bang! Almost nothing? Well, almost nothing, but cephalopods. But we'll come back to them. Each barren layer of rock represents an event, an extinction event, in which something catastrophic happened to eradicate the majority of life on the planet. And each of the 5 worst times this happened, a new blend of life forms followed behind it, different from the last. With the exception of the cephalopods. They just keep going. Here's the story of the Earth's 5 biggest mass extinction events, and a cautionary tale for what we expect as we hurtle deliberately into its 6th. Let's begin by defining some terms. An extinction event, biotic crisis, or mass extinction event, is a rapid reduction in biodiversity. This term, biodiversity, is carrying most of the weight here, so let's dip into it a little. To understand biodiversity, we need a brief overview of an ecosystem. Ecosystems are made up of communities of various organisms. We might think of DeviantArt or streamer gossip clubs to be communities, but from an ecological standpoint, they'd just be populations, since they are, let's exclude the furries here, the same species. Communities are made up of all the species in the ecosystem that interact either directly or indirectly with one another. So, your cat, your neighbor's iguana, the flies that eat its poop, the birds that eat the flies, and your cat that eat the birds are all members of your ecological community, as are the plants and fungi that make the place look nice and provide oxygen and groceries. Biodiversity, then, is a measure of how many different species there are in this community or ecosystem. For example, MAGA folks may gather in the thousands, but their species diversity would still amount to a 1, and their genetic diversity probably isn't all that hot either. So they could, and I'm not saying they should, disappear without doing much damage to the ecosystem. It wouldn't be a significant loss of biodiversity, even if their population would disappear. So, this important distinction between amount and diversity sets up the definition of a mass extinction. Still following? Great! Now for the death. Extinction is a natural process of evolution. In fact, it's a necessary one, since organisms evolve at random, and the vast majority of these random changes have to die off to allow for the most lucky and effective ones to stick around. So, there is what's known as the background extinction level. And this is the rough rate of species dropping off the radar because they just weren't all that great. In a mass extinction event, extinctions happen at a rate that's far greater than the expected background level, and the rate of species evolution isn't high enough to replace what's lost in time. A reduction in population is therefore not the same as a reduction in diversity. In fact, it can significantly help diversity when organisms die and population numbers fluctuate. Just think of all the little critters who will dine out on your husk when Charon finally ferries your soul across the river Styx. Further, population decline can be reversed, whereas species extinction is permanent. And when the diversity drops, that can become an issue. And this is because all the members of the ecosystem fill various roles. The more variety you've got, the more overlap there is in these roles, and the more resilient an ecosystem then becomes to the reduction of 1 or 2 populations within it. But enough of all that. You didn't come here for an ecology lesson. You want to hear about everything being exploded. Let's look at the Earth's first major extinction event, and you'll see how this becomes relevant. The Ordovician Silurian. Around 540 million years ago, life in the oceans erupted with diversity. Such was the increase in brand new animals. This moment of around 20 million years saw animals in the ocean trying out a plethora of new survival strategies, such as using jaws to eat other animals with, or, if you were the other animals being eaten, spines, to encourage them not to. It was around this time that a group of mollusks, members of the same phylum as those slugs that eat your lettuce, evolved their basal forms. Back in those days, they all developed shells so that they could both eat and not be eaten. They also had tentacles protruding from their heads, which lent them the nickname Cephalopods, from the Greek for head legs. Today, these are the octopuses, nautiluses, squids, and cuttlefish. But it wasn't just them. pretty much all life around you had an ancestor that emerged during the Cambrian. Though this was long before animals migrated up onto land, and even a long time before plants were invented. So everything was happening in the ocean, until one day, it wasn't. Picture this scene. Almost 100 million years of biological carrying on occurred in the oceans of the time. Think of the coral reef as it was 50 years ago, and then multiply it by billions. If this time, almost all the land that we have was smushed up together like a wet cookie dough dropped on a kitchen floor into a supercontinent called Gondwana. That's a lot of coastline, a lot of reef, and a lot of shallow, warm, and beautiful sea habitat for life to thrive in. 40 million years into this splendorous stint of speciation, life diversified even further, with organisms branching away from the coast to investigate the wider reaches of the open ocean. Suspension feeders and pelagic animals, including cephalopods, moved away from the safety and predictability of the coastlines and became marine explorers. While the Cambrian explosion created pretty much all modern animal phyla, soon after, this so-called Great Ordovician biodiversification event filled them out with many of the classes and order of life forms we see around us. Then, 445 million years ago, something happened. Something so enormous that 85% of all these species disappeared, all at once. This wasn't a population decline. This was a species eradication, a massive tanking of biodiversity. It's worth pointing out that all at once, in geological context, can still be 1.4 million years, which is roughly how long this event took. This was positively sudden by evolutionary standards, and we'll come back to why that's important to remember. This something, called the Ordovician-Silurian extinction event, looks to have happened over 2, or some suggest maybe 3, separate pulses of decline. Both were marked by a conspicuous lack of oxygen all over the planet and a high amount of toxic sulfide production, just like you might expect from a colossal volcano. So, one hypothesis for the proximal cause of this event is an eruption. Other suggestions go a little celestial. There is the suggestion that a hypernova, think of a supernova with ADHD, from a star 6,000 light-years away could have sprinkled the planet with a brief shower of gamma radiation, enough to strip off the atmosphere and kill off all the surface algae in the ocean. You know, algae that is responsible for photosynthesis, and therefore oxygen production for everything else to breathe. Ultimately, whatever it was, this was a really, really, really long time ago, so it's possible we'll never know what caused it. But it remains to this day the second most potent extinction event by percentage of species destroyed, so far. This event marks the transition between the prehistoric marine utopia of the Ordovician and the rise of life on land. Next up, the Late Devonian extinctions. The Ordovician-Silurian extinction was, no question, a massive screw-up. Almost everything died, but life prevailed. Much of it in the form of cephalopods, who carried on doing what they were doing, but also in the form of other animals still around today, like horseshoe crabs, coelacanths, and weird sharks, our fear which dates back to a time when we too were still fish. Perhaps most significantly, the next wave of evolutionary experiments were terrestrial plants. The Silurian period was the first time that biota from the ocean had migrated up onto the land, and tiny organisms like moss grew to form vast mats of low-lying mini-forests around lakes and rivers, linking together networks that have become the pioneers of the so-called Silurian Devonian terrestrial revolution. But not everything cool happened on land. In the ocean, jawless fish were expanding all over the place. Things such as the alien-like hagfish and lampreys around today were commonplace, and actually were doing better than those with jaws, which may explain how our bony fish ancestors managed to fly under the radar. This is where they show up too. 443 million years ago, the Silurian gave way to the Devonian period, and with that, it was looking all pretty cute. Millipedes were invented and trundled around on land as representatives of some of the earliest terrestrial animals. Freshwater fish evolved out of the ocean and into lakes and rivers. Plants got more complex, figuring out roots, leaves, and vascularity. And in the ocean, jawed fish made a big comeback. In fact, the Devonian period is known as the age of the fishes for this reason. But all these organisms would be the plants that throw a spanner in it. So, spoiled for real estate and nutrients with little competition on land, they set to work gobbling up the carbon in the atmosphere to help them grow. A rapid decline in CO2, a very familiar greenhouse gas, may have led to runaway cooling across the planet, and these newly invented roots released copious amounts of phosphorus-created algae blooms that compounded the process. By the Late Devonian, 372 million years ago, at least 2 such events, about 13 million years apart, wiped out around 70% of all species. So you can blame the plants for our current lack of armored placoderm fish. I know it's been a long time, but it still hurts. However, yet again, cephalopods persisted. And by this time, they mostly do it as ammonites, the snail-looking fossils that littered the Jurassic coasts. The Permian Triassic Extinction Event. Speaking of the Jurassic, we're about to touch on the origin story of the dinosaurs. And stick around for this one, because it's a doozy. From the wreckage of the Late Devonian came the same sort of re-emergence we're starting to appreciate from life. Sea levels rose again, and once more, reefs proliferated around the coastlines, and the Carboniferous period emerged. This was characterized by enormous primitive tree mosses with stems of up to 30 meters tall. And maybe I'm a bit biased, but one of the most significant events was the emergence of the tetrapods on land. Tetrapods began as fish, ancient relatives of the modern lungfish and coelacanth, who still technically are tetrapods, and evolved into proto-amphibians, reptiles, and consequently, every single land vertebrate, including you. Fun fact, this means that you are more closely related to a lungfish than a lungfish is to a salmon. Humbling, isn't it? This was the time that some cephalopods internalized their shells, and many soft-bodied species arose. Animals like the cuttlefish and octopus, shelled versions persisted too. Ammonites were playing a small role in the Permian, but would prove to be a big star later on. Millipedes, having been around for ages by now, grew to 2.6 meters long amid an oxygen-rich environment that reduced the physical limits of their body size. This was also the time that monstrous dragonflies, like Meganeura, roamed the forests, with their 60-centimeter wingspan, probably sounding like a petrol lawnmower. Climate change would ultimately lead to the collapse of the Carboniferous rainforest. Some say this counts as a mass extinction event in itself, and this would mark the end of the period and the start of the Permian, in which land vertebrates diverged even more. Amphibians, faced with increasing desertification and arid landscapes, fared badly, while reptiles began to take over their niches. But just as they were getting a foothold, an event affectionately termed the Great Dying happened. Remember, Earth has experienced at least 5 mass extinction events already by now, so this one must have been bad. Really bad. Yeah, not a happy time to be a reptile, or almost anything else for that matter. This was the most severe extinction event known by far, with up to 96% of all species eradicated. At least 80% of marine species were wiped out, along with 70% of terrestrial species. All trilobites left the stage, and did sea scorpions and 98% of snail species. To make things even more shocking, some estimates put this decline within the frame of just 50,000 years or less. It's thought to have occurred as an enormous volcano released far more carbon dioxide into the atmosphere than had any business being there, leading to a catastrophe of climate change. To put it into perspective, climate scientists are warning of a tipping point of 1,200 parts per million of carbon dioxide, beyond which stratocumulus clouds will disappear for the Permian Triassic extinction. There was thought to have been around 4,000 parts per million, rising to 8,000 parts per million in the years that followed. It's thought that the coal that had layered up from the gargantuan forests of the Carboniferous was ignited by magma flows, resulting in a truly devastating amount of greenhouse gases. This was, essentially, a planetary Dutch oven, and almost nothing made it out alive. The Permian Triassic extinction sent 2/3 of terrestrial vertebrates straight to hell, and it would be 30 million years before their numbers are back up to pre-extinction levels. Cephalopods, of course, bounce right back. But off the back of the worst extinction event known to man came 180 million year long reign of our reptilian overlords, the dinosaurs. The Triassic-Jurassic extinction event. The Triassic period was the alpha version of dinosaur development program, and the world was hot and wet around this period, even the poles. Aquatic insects became increasingly diverse and repopulated land too. And after the initial hot period of the early Triassic, amphibians started to return in a big way. As for the reptiles, there was a remnant lineage from the Permian that exploded in diversity early on and would end up dominating the landscape. These groups grew long necks, or specialized herbivorous jaws, or elongated limbs for gliding, and then used these weird adaptations to radiate into various newly exposed niches. Reptiles branched into herbivorous, carnivorous, aerial, aquatic, and semi-aquatic niches, one of these being the archosaurs, the ancestors of crocodiles and birds. By the late Triassic, one little-known branch of the archosaurs, the dinosaurs, were showing signs of really kicking things off. But before they could get going, around 201 million years ago, another pesky extinction event went off. Between 70% and 75% of all species disappeared. Again. I know, right? This is very frustrating, but stick around. It's a trilogy. The Triassic-Jurassic extinction is one of the messier events of its kind, being of unknown origin and taking its sweet time, too. Some think it might have occurred through a series of events spanning up to 17 million years, though what these events were is still up for grabs. It's possible that there was a long series of events that capitalize off one another to result in almost total ecological collapse, but this is more or less a cold case at this point. What is known is that the equatorial supercontinent, Pangaea, was separating at the time, and with most toxic breakups, there was a lot of explosive hot gas and no clear definition between the before and after. A sudden warming event, possibly caused by volcanism, marked the end of the Triassic, and a lot of the life it had been home to. But dinosaurs came out of it pretty well. Of all the reptilian groups, they were the luckiest, and they set to work repopulating the planet, which they held stable for almost 150 million years longer in what would become known as Jurassic Park. The Jurassic period. Cephalopods came too. The Cretaceous-Paleogene extinction. We're going to have to gloss over a lot of this, because the peak of dinosaurdom was phenomenally long. It appeared that the Earth had recovered from much of its indigestion, and the breakups of the supercontinents led to stabilizing ocean currents for a long time. Life, had found a way. Or so it seemed. Dinosaurs diversified, as did flying and swimming reptiles, and it was during the Jurassic that the first animals we have come to know as birds arrived. Cephalopods, in the form of shelled ammonites, were now the most abundant sea creature on the planet. But more than this, the tiny little prey animals burrowing for their lives to get away from these terrifying reptilian monstrosities were early mammals. The Jurassic period gave way to the Cretaceous, but not because of any catastrophe. It's mostly a marker of different climates and ecosystems. The Cretaceous was ironically home to most of the species found in Jurassic Park, and continued this unbaited archosaur dominance scheme for around 80 million years more. Seemingly unstoppable, the reptilian reign was cut short when a big rock fell on top of them. In the Cretaceous-Paleogene extinction event, one, perhaps two or more, asteroids hit the Earth around the time the dinosaurs disappeared. Well, most of them. Some of the theropod dinosaurs survived and still flap around today as what we call birds. In the ocean, despite being so numerable, ammonites became extinct too. It's likely that their buoyant shells prevented them from hiding in the relative stability of the depths to emerge later when the coastline became clear, as their squiddy and octopody cousins did. Cephalopods continue to be awesome, but for how long? The Holocene extinction. And now we come to the reason why all this is important. The extinction events listed so far are just top 5 such disasters. Waves of extinctions come and go as the climate wafts between hot and cold, dry and wet, oxygenated and suffocating. Life as a whole is resilient, but its existence isn't a given, and its path isn't linear. And what we humans are doing on the planet is currently causing what will become the 6th mass extinction event. This time, we know exactly what the causes are. From early human expansion in the Pleistocene epoch, biodiversity has been tanking. Current estimates of extinction rates are now between 100 and 1,000 times faster than the background extinction rate, and getting faster. The rate of this loss puts this one right up there with the Big 5 events, and while most of the above happened over more than a million years, humans have done all this in less than 15,000 years. Dinosaurs held the fort for almost 200 million years, and we've only just learned how to put a stone on a stick, and we're already blowing it. Starting with the largest megafauna, the mammoths, rhinos, the elephants, and whales have all either gone extinct or are on their way out. And with our greenhouse gas emissions causing climate change and ocean acidification, and the deforestation removing wildlife habitats, it's not looking good for almost everything else either. 12% of bird species, that's 12% of dinosaur species that survived all this time, have been eradicated by human activities already, and 60% of animal populations in total have gone since 1970. But, as we have mentioned, populations aren't species, and this means that anything left with a viable population can bounce back, if we let it. Regardless of what happens though, life seems to always break through to the other side. Even if it takes 30 million years, life will return. The question is whether we, and any of the other animals we share our world with, will be around to see it. Well, cephalopods will. We can be sure about that. That's all for today. For more prehistoric chit-chat, subscribe and check out our previous videos. And as always, stay curious, Fossil Files.